It's the future of electricity, and it is here now. Fault-managed power systems. That is today on the Code Authority. I'm Phil Doherty, and welcome to the show, everyone. Today, our guest is Ken McKinney. He is a principal engineer here at UL Solutions, a global leader in safety science. Ken, thank you very much for joining us today.
Thanks, Bill. I'm glad to be here.
All right, fault-managed power systems are popping up in more and more places. They are relatively new, and they have big implications across the built environment. So first of all, could you just describe for us basically what is a fault-managed power system?
Sure. FMPS, or Fault Managed Power Systems, also known as Class 4, is a fairly new type of electrical distribution system. These systems consist basically of a transmitter, a receiver, and some cable, known as Class 4 cable. These systems are characterized by sophisticated monitoring and control systems that monitor the Class 4 circuit for faults and control the power that is transmitted to ensure that energy delivered into a fault is limited. Class 4 power systems deliver from Class 2 or Class 3 systems, which people may be more familiar with. Class 4 systems are not power limited at the source, but they are power limited with respect to the risk of electric shock or fire hazard between what we would call the Class 4 circuit, or the output of the transmitter, and the input of the receiver.
Okay, now this is going to sound like a really basic question here, because it is. But for some people who might not necessarily be as plugged in, so to speak, to the subject matter here, first of all, just in a basic system, what is a fault? Is it like a lightning strike hits a power line? Is there an earthquake? What constitutes a fault?
A fault could be a short circuit. I think we're all familiar with that, where we all have a breaker panel in our house, right? With all the breakers. If something shorts, the breaker will open. It will kill power to that circuit to make sure that nobody gets shocked or anything like that until the fault is corrected. But with fault managed power, it could be a short circuit. It could be a line to ground fault. It could be a line to line fault. And these are the conductors that I'm talking about. So typically things are grounded. So if you have a fault, the fault current would go to ground. So those types of things. Short circuit. If the insulation system was broken on one of the conductors and somebody actually touched a live wire, that would be a fault. So these things basically, like I said, they self-monitor. So really any type of fault that would cause a shock or fire hazard can be mitigated before there's any damage done.
Okay, so in a fault-managed power system, are there still circuit breakers? Like in the future, if my house has like a fault-managed power system, am I still going to have like a breaker box in my garage?
It would be on the input of the transmitter, but what we call the Class 4 circuit, because you have basically, as I mentioned, a transmitter, a receiver, and some cabling in between, there wouldn't be a typical circuit breaker that would be necessary for that circuit, because it would self-monitor on its own, and the energy that goes into that fault would be safe and controlled. So typically, Class 2 systems, or power over Ethernet systems, or communications type systems, are very limited in terms of voltage and current and power. These are not the only limitation you have on the output of the transmitter is the voltage. There is no power limitation. There is no current limitation, as long as you meet the criteria and the standards that we've created for this. So there's no shock hazard. There's no fire hazard. So it would act like a Class 2 system, which is a limited energy system.
Even though the actual energy is more or less unlimited. That's a phenomenal breakthrough.
That is correct. It's unlimited until there's a fault. And then that energy into that fault is limited because everything is monitored and controlled.
That is fascinating technologically. Okay, are there any installation or certification requirements for these systems?
Yeah, that's a great question, because when these systems were first introduced into the market, there were no installation requirements, there were no certification requirements. So that put a lot of pressure on the AHJs, authorities having jurisdiction, that were supposed to, approve these systems for installation. So UL Solutions, we participated in the National Electrical Code process to help develop requirements for FMPS under Article 722, which covers the Class 4 cables, and Article 726, which covers the actual fault managed power system. These requirements first appeared in the 2023 electrical code. That is published every 3 years. So the 2026 code is coming out soon, and those requirements have actually been enhanced. In addition, UL Solutions, we formed a working group to develop certification requirements for these types of systems. The result of that working group was 2 outlines of investigation. UL 1400-1, which would cover the safety requirements of the system, and UL 1400-2, which would cover the requirements for the Class 4 cables. Currently, the working group we're hard at work on issue 2 of the outline of 1400-1, and we hope to submit that as a consensus standard once that work is done. We hope to be done in a couple months. The end of October is kind of that's what we're hoping for. I'm not going to promise anything, but that's when the code work starts for the 2026 code. So we're hoping to be done before all that starts.
All right, ample work ahead of you there. What are some of the bigger technical issues with this technology that, like, our current certifications that we're working on address?
There's a lot of testing involved, as you can imagine, because there's all kinds of different faults that we have to account for. So we're basically, simulating these faults, ground faults, touch faults, that type of thing. And we're measuring that energy. We're measuring the voltage. We're measuring the current. We're looking at the waveforms. Does the system cut off in an appropriate amount of time where we wouldn't have a ventricular fibrillation type of situation, which would stop somebody's heart? Or are they able to let go of a system if they were to touch a live conductor like we had talked about before? Because a lot of times the reason people get shocked is because they grab onto something and they're not able to let go of that because the voltage and current are too high. So there's a lot of testing with regards to that. We also do functional safety evaluation, which looks at, if there's software components to these and that type of thing. So it's basically another investigation from another perspective that looks at kind of the same thing and the discrete components and how those work to make sure that, if something happened to those, that the system would still work as it's supposed to.
Okay, you mentioned a couple times here what happens when somebody would accidentally touch a live wire. And clearly that's something, like you said, that we're just testing for. Just out of curiosity, how do we test that without actually hurting someone? What do you do to actually test someone can let go of this if they touch it?
Well, there's been a lot of research done with regards to, voltages and currents and that type of thing. So we know what those levels are, and we know the time that those have to cut off. So, we would simulate a short circuit. In other words, we would take 2 wires, put it across the 2 conductors that are coming out of the transmitter, and just short that with a switch to simulate a short. And then we can measure that voltage and that current and that time, from the time the fault starts till the time the fault is cleared or the system cuts off. And we know what those values are, so we can measure that against known graphs to make sure that those values are under the values that we're looking for.
Has UL Solutions certified any FMPS systems yet?
We actually have 3 certifications for fault managed power systems, the actual receiver and transmitter, and we actually have 11 certifications for Class 4 cable. So, it's and that's only after a couple of years. So, we're obviously doing certifications every day, and we expect more in the future.
Okay, clearly it's just a couple of years now that we've been working with this. Is this technology really commonly employed yet? Is it widespread? Is it just getting started? How common is it out there?
It's disruptive, is what I'll say, because it's gaining traction. There is a lot of applications with regards to cell phone towers and 5G applications. That's kind of where it started. So Football stadiums, Hard Rock Stadium in Miami being one, and a lot of others have this type of technology because people go to a football game, a basketball game, baseball game. They want to take pictures. They want to send pictures to their friends. The folks that own the stadium are, invested in making sure that people have a good time and that people's phones work. We all want to communicate all the time. That's kind of the world we live in. So that's one of the big applications. So yeah, these are pretty much all over the place, whether people know it or not. It's fairly new, like I mentioned, and we're trying to educate. Myself, I've done presentations for code authorities all over the place. Our regulatory division has also done presentations. So yes, it's out there. Again, people might not know what it is, but it's installed, and there are more installations every day.
Okay, so let's say, for example, a company has a widget factory. All right, it's an established factory and it's running on Class 3 power. Okay, and the same company wants to build another widget factory. All right, same widget, same everything else, but the new widget factory has Class 4, or the fault managed power system.
Right.
What can the Class 4 factory do or have that the Class 3 factory doesn't?
It would essentially, you could have basically longer installation runs. In other words, and it would be Class 2 or Class 3 or Class 1. But, if you're for a Class 2 or Class 3 system, because of the voltage and currents and limitations that are involved, you can only run a conductor so far. Typically 100 feet for a power over Ethernet system, or a Class 2 system, or a Class 3 system, 100 meters. Excuse me, not 100 feet, but 100 meters. But for Class 4 systems, you can run these conductors thousands of feet. So you could have one run to do all your lighting, all your switches, all your internet connections to make sure that you have connectivity within the building. And it would simplify the installation. Instead of having all of these smaller systems, you could have one big system for a lot of these applications. In fact, there's a hotel in Fort Worth called the Sinclair. All of the switches are powered by a Class 4 or FMPS system. They're Cisco switches, but they control basically all the digital lighting, all of the window treatments, all of the mini refrigerators, all of the smart mirrors that are in this hotel. And they use Class 4 because the building was an office building, and it was designated as a historical building, and they wanted to turn it into a hotel. So the city government said, fine, you can do that, but you can't deface the building. You can't knock anything down. So the fact that these conductors or these Class 4 cables do not have to be in conduit, you can run it around walls or through walls, just like a piece of Romex is in your house. It made the installation possible. So that there's just a lot of applications where this could be used.
So why don't the Class 4 cables actually have to be in conduit? Like, to a guy like me, that sounds dangerous. Oh, wires not in conduit. But why is it safer with Class 4 cables? Why is that possible?
And you're absolutely correct. So for Class 1 wiring, like you have receptacles in your house, you have 120 volts coming out of the receptacles. That's a hazardous voltage, and you have currents that can shock and kill people. So the fact that this system self-monitors, and we have tested for all of these different kinds of faults, you could actually touch a live conductor and you would be fine. And that's why they don't have to be in conduit. Now, I will preface that with saying, if there are building codes that say, we don't care what it is, you have to put it in conduit, then you have to adhere to certain cities and certain building codes. But typically they would not have to be put in conduit.
Wow. Okay, now just to be clear, we're not recommending that people actually go actively grab these wires or anything. But that's fascinating to hear that you actually can, and it's a much different outcome than, say, like the Class 1 wire. Wow.
I actually have a video, Phil, of a guy with if you know what an Edison base for a light bulb is, that's just the base where you screw the bulb in, and that's where your electricity. Actually sticking his finger in that and touching where the light bulb would touch, and there's another light bulb in parallel, and it cuts off. So the system, yeah, I wouldn't want to be that guy that was the first one to do that, but that just kind of demonstrates what these systems do during a fault, and not just a touch fault. There are other kinds of faults too that we talked about.
I hope he got a bonus for that one in his job at the very least.
Yeah,
Come on, positive performance review.
Absolutely great.
All right, Ken, thank you very much for joining us today. This has been very fascinating. Learned a lot of new stuff here. And UL Solutions and the Code Authority community is here to help everyone. So please sign up for our newsletter. Go to ul.com. You can do that there, and you'll get insights from lots of other experts like Ken here. We are also on LinkedIn. We're on Facebook. We're on YouTube, and we're on Spotify. So please check us out in all those places. We hope to see you there. Thanks a lot for joining us.